Alrighty, what we're gonna do in this video is convert our points back and forth. So remember, the normal points that we have are rectangular points, our Cartesian points are x, y. But we're gonna go between x, y and r theta, our polar points. So I need to turn x into r and y into theta. So here's your conversions. R, you get r squared equals x squared plus y squared. But if I'm just gonna solve for r, I need to get rid of the squared. So this just becomes the square root of x squared plus y squared. Just to give us a little shortcut there. And then if I'm solving for theta, I need to get tangent out of the way. So I'm gonna do tangent inverse of y over x. So I'm just kind of solving this to make it easier for us later. X is our cosine theta, y is our sine theta. So that's what we're gonna use for x and y. Okay, so first let's look at, they give us polar coordinates and I'm trying to turn them back into rectangular. So right now, this is r and theta, and I want it to be x and y. I made a note here to be careful of the quadrant. That's not gonna be important here, but it will be important for the next section. So we're gonna practice that just to get comfortable with, okay, this is quadrant this, my answer needs to be quadrant this. So 5 pi over 6 is in quadrant 2. Almost said 4. So my answer in rectangular form also needs to be in quadrant 2. So first let's get x. So x, we're gonna do r cosine theta. R is 4. Cosine theta is 5 pi over 6. All right, we gotta know our unit circle for this because I need to know what is the cosine of 5 pi over 6. What is the x value at 5 pi over 6? So 4 times, that's negative root 3 over 2. And then we'll multiply that together and simplify. You should get negative 2 root 3 because 4 over 2 is 2 and it's negative. Okay, there's our x value. Our y value is the same thing, but we're doing 4 sine theta. So 4 sine of 5 pi over 6. So that's 4 times 1/2, which is 2. So here's my x value, here's my y value. I just need to write it as a coordinate. So negative 2 root 3, 2. Any questions? Yay, not too bad. You just gotta know your unit circle. So now let's look at the next one. Oh, here's what you need to do for quadrant. Sorry, I forgot. Quadrant 2. So this x value goes left, the y value goes up. If you go left and up, you're in quadrant 2. So we did a good job. Now this one, 45 degrees is in quadrant 1. But remember, this makes it reflect. So from quadrant 1, go across. Now we're gonna be in quadrant 3. So I can check that in the end. Let's do x first. So negative 2 cosine 45. So it'll be negative 2 times root 2 over 2. Those 2's cancel, but don't forget the negative. So negative root 2 for x. For y, probably gonna get the same thing since it's 45 degrees. But let's show our work, sisters. Okay. Negative 2 times root 2 over 2. Those 2's cancel, so just negative root 2. So my coordinate will be negative root 2, negative root 2. If you go left and down, that's quadrant 3. Wow, give yourself a high five. Okay, y'all pause this video and try that last one, see if you got it, and then replay and you'll check your answer. Did you pause it? Okay. So this I'm going down pi over 3. So I'm technically going to be using 5 pi over 3. That's in quadrant 4. So if you didn't know that, and now you need to re-pause and do it again, sister, do that. Okay, x is 6. Cosine, I'm going to use 5 pi over 3. Okay, that's 6. You found that that was 1/2, which is just 3. And then for y, you did the same thing, but sine. So you did 6 times negative root 3 over 2, which simplified to negative 3 root 3. So your answer was 3, negative 3 root 3. And that goes right and down, which is in quadrant 4. Okay, so that's doing polar to rectangular. Now we're going to go the other way. Rectangular is what's given. These are x and y's. I want to turn it into r and theta. Okay, they give us an interval here. We're going 0 to 2 pi. They give us that because we're going to be using the tangent inverse. And remember, tangent inverse is restricted to quadrants 1 and 4. But by saying to use this interval, they don't want us to use our inverse restrictions. So I'm going to use the whole unit circle here. So letter A. Let's find the radius. Oh, let's figure out what quadrant we're in. So x is positive, y is negative. So that means we go right and down. So that's going to be in quadrant 4. Okay, right now this is x and y. I'm turning into r and theta. So r, we're going back up here and using the square root of x squared plus y squared. So the square root of root 3 squared plus negative 1 squared. Well, root 3 squared is just 3, 1 squared is just 1. The root of 4 is 2. Okay? Let's do theta now. So I'm taking the tangent inverse of y over x. So tangent inverse negative 1 over root 3. So I'm thinking where in my unit circle is y1 and x root 3, and it has to be negative. That happens in 2 places, 5 pi over 6 and 11 pi over 6. Well, I can only have one answer. So that's where my quadrant comes into play. Which one of these is in quadrant 4? 11 pi over 6. So when I write my answer is 2, 11 pi over 6. Okay, let's try letter B. So I have 3, 3. Let's solve for the radius first. Square root of x squared plus y squared. 9 plus 9 is 18. That simplifies to 9 times 2, so 3 root 2. Okay, sister theta, tangent inverse of 3 over negative 3. That's just tangent inverse of negative 1. So where on your unit circle is tangent negative 1? Well, that happens at 3 pi over 4 and 5 pi over 4. Oh my gosh, we forgot. I have to pick based on which quadrant this is in. Okay, so x goes left, y goes up. That's quadrant 2. So which one of these is in quadrant 2? 3 pi over 4 is. So my answer, 3 root 2, 3 pi over 4. Okay. Now the fun ones are when you have a 0. Because if I go 0, -2 on a X and Y axis, that's between quadrant 3 and quadrant 4. Well, what's the only angle right there between 3 and 4? 3 pi over 2. So I have to solve for theta. I know if X is 0 and it just goes straight down is 3 pi over 2. But let's go ahead and solve for the radius. So square root of 0 squared plus -2 squared. Well, that's easy. So it's just 2. So my answer is 2, 3 pi over 2. I love zeros. Okay. This one is a crazy girl. You will need your calculator for this one. Okay. Put your pre-AP pants on. So -512 is in quadrant what? 2. So let's find the radius. That'll be 25, that'll be 144. That's 169, which is 13. Well, that's pretty. Okay, let's find theta. Y over X. Now this isn't on my unit circle, so that's why you need your calculator. So go ahead and type this in your calculator, and it will give you. Okay, but now we have to think about this. If I'm going to graph this, -67-ish degrees is like here, but I want to be in quadrant 2, so I need to reflect it across to over here. Well, what do we do to reflect across? You have two options. You can either make 13 negative to reflect it across. So one of my answers could be -13 and then -67.38 degrees. Or if I'm trying to get from here to here, that's just adding 180. So I could just add 180 to this and keep 13 and use 112.6 degrees. So either one of these works. But again, this is why you have to know the quadrant. You have to know where you're trying to get your point into. So always keep track of that. Go ahead and turn the page though and practice converting back and forth again. The same type of problems are on page 6, and be sure to check your answers in the answer key folder at Schoology. Bye!